I'm going to start. Let me start first. Okay. So as I told you, our lesson is equations and inequalities. I'm going first to talk about equations, and then we're going to start with inequalities. First of all, for equations, you know that we have equations of first degree, second degree, and third degree, fourth degree, etc. Okay, what's the meaning of first degree? Do you know what's the meaning of equation of first degree?
Like, for example, it's like there's no powers, like to the power of 1 or something.
Exactly. To the power of 1 means it's in the first degree. To the power of 2 means in the second degree. Okay? To the
and the power of 3 is degree.
Exactly, and so on. What does that help me in? In the first degree, the solution, you know what's the meaning of the solution or the root?
Yeah.
How many roots do you think we're going to have?
Mainly we're going to have like 1 root.
Yes, maximum of 1 root, and we might have, for example, no root, right?
Yeah.
Exactly. But when I have a second degree, how many roots do I have?
Oh, we can have maybe 2 because since it could be the positive and negative version.
Exactly. Or sometimes we can have.
Or we can have like
1 root
as well.
Or no root. No root. I will give you examples. Like for example, if we have, I'm going to write this, x squared minus 2x plus 1. Okay? Can you give me the factorized form of this?
Okay, so it's supposed to be a minus b squared, right?
Exactly. So it's x.
Okay. X minus 2 squared.
Minus 1.
Right. Minus 1, yeah. Okay.
Yes, x minus 1 squared. If I put this equals to 0, then we take only x minus 1 equals to 0, then x equals?
Then x equals to 1.
Exactly. So although it's in the second degree, but we had only
one solution.
Exactly. So in the second degree, we can have maximum of 2 roots. We can have 1 root, or sometimes we can have no root.
No solution. Yeah.
Okay. Same thing for third degree. We could have.
Could we have like maybe 3 roots? Or
3 roots, maximum of 3. Yes. Maximum we can have 2 roots, 1 root, or sometimes nothing. Right?
No root.
Okay. So our lesson now, it's how we can solve in order to find the roots.
Okay.
Okay. This is very easy. I will share with you something. Just a second. Yes. Can you see this exercise?
Oh yeah, I can. I can see it.
Yes. All of these are equations that you have to solve in order to find the roots. Sometimes you might have no root. Sometimes you could have 2 roots. It depends on the degree.
Yeah.
Okay. Out of all of these, I'm going to solve this one, this W and X.
W and X, all right.
Yes, because I think, like, for example, in A, B, I think you are able to solve these alone.
Okay, so like I'll solve them alone like later and then send them to you.
Exactly, as if you are solving a normal equation.
Okay. Yeah.
Okay. Look, I'm going to solve D, W, and X. Okay. I'll start with D because I have something special to tell you, and then WX. Okay.
Okay.
Yeah. Let me start. I'll go back to the white screen. Okay. When we have fractions, kind of like, for example, let me write it first. Okay. Here we have 2x minus 1 over 6, yes?
Over 6, yeah.
Plus 3x plus 2. I will share this worksheet, by the way, at the end of this lecture, so you would solve it, okay?
Okay, yeah.
Yeah, over 15 here, and this is 14x plus 9. What's the first step you think you are going to do in order to solve this equation?
In order to solve this equation, Should we perhaps like first we should what's it called, like separate like the x's and the unknowns and the knowns?
Of course, this is the main objective. But first,
Yeah.
let us do the same denominator for all.
Oh yeah, the same denominator for all. Okay.
Exactly. What do you think the common denominator for 6, 5, and 15 is?
6, 5, and 15. All I think of is 30.
Exactly. Perfect. It's 30.
30.
So what do you think you're going to multiply the first fraction by?
By 5. All of
Very
it.
good.
All of it by
That
5.
means I have to multiply all this by 5. Perfect. Now the second fraction?
By 6.
Excellent. So that means I have to multiply all this by 6. And what about the last one?
By 2.
Very good. So now what do you have, Kalam? The same denominator for all, right?
Yeah.
Which is?
30. So 5 2, it's supposed to be 10x.
30. Yes. Let us expand the numerators. Okay. So for the numerators, tell me.
Numerators. So for 2x, 10x minus 5.
Plus.
Plus 6 and 3, 12, 18x.
Plus
12.
Very good. Now the second one.
The second one is 2 times 14, it's supposed to be 28.
Yes, 28x plus
28x plus 18.
Perfect. Now, what I'm going to tell you is very important. Whenever you have two fractions, one to the right and one to the left, with the same denominator, what you can do is get rid of the denominator.
Oh, okay.
Cross it out. No more denominator because it's the same.
Yeah.
Okay, that's Heidi, it's a simple thing that you can do, but it's with less calculation.
All right.
Okay, so what do we have now?
So now we have only 10x minus 5 plus 18x plus 12.
So now I will put the x's to a side and the numbers to a side, and it's much easier because I'm dealing only with monomials without fractions.
Yeah.
Help me, 10x plus 18x.
And it'll be minus 28x, I think.
Very good. Yeah.
Equals to plus 5 or just 5.
Plus 5.
Minus 12.
Minus 12.
And plus 18.
Very good. And now you're going to solve it normally. Add them, subtract them, and solve the equation. Okay?
Yeah.
So the only hint which is important is that make the denominators the same to get rid of them.
To get rid of the denominator entirely.
Exactly. Okay, let me now solve something that have x in the denominator. Okay,
I'll just let me write this like down this example real quick, and then
yeah, you can take a screenshot, or I don't know.
It's easier for me to write so I can memorize it easily.
Okay.
Okay. I wrote them.
Okay, let us continue. So I'll clear this. Let us write the second example. Okay, we had x squared, okay, plus 4x minus 3 over x squared equals 1. Okay, now, Kalam, the question is just calculate or solve. Sorry, solve. Okay, but you have to pay attention. There's something that you have to do without even asking you is the condition.
Oh yeah, so like
that
the x should not be equal to 0.
Yes, x squared, the denominator, all of it, x squared minus 1 shouldn't be
equal to 0.
How do you solve this?
Basically like any normal equation. So we take one to the other side first, or we can do the.
Do you know why?
Oh, so because it can be, we can have like two conditions, like
Because
if
yes, you sometimes
yeah.
when you take the one to the other side and you put radical, you're going to forget the minus. So I
Oh, true,
prefer
true,
if
true.
you do factorize. Okay?
Yeah, like oh yeah, factorization.
Yeah. So x shouldn't be.
So x shouldn't be 1 and plus 1.
Very
Minus
good.
1.
Excellent. Okay. Now you can do normal thing. You can continue the equation, but the condition you have to do it without even asking.
Okay.
Yeah. How do you solve this equation?
Okay, so are we supposed to multiply the denominator on both sides?
So
Yeah, do we just multiply the denominators like on both sides so we can cross them out
yes,
like last time?
you mean cross multiplication, right?
Yeah.
Okay, that's it. Yeah. So what do I have?
Okay, so then we have x squared plus 4 x minus 3,
Very
like
good.
normal,
Equals.
equals x squared minus 1.
Very good. Now what do we do?
Okay, now what do we just like
Bring them
take
to
the
this
normal
side.
to the other side and then the unknowns to the other
Very good.
side.
Yeah. So x squared minus x squared plus 4x equals
To minus 1 plus 3 or 3 minus 1.
Yes. Now the x squared goes with the x squared,
They
and we
cancel.
have yes
4x
4x equal,
equals 2
and then
and x is equal to 2 or 4, which is equals
is
to
half.
1 over 2.
Very good. So it's easy, right? Sometimes
Yeah.
it seems like it's hard, but it's very easy, right?
Yeah.
Yeah. The last one I'm going to do, it's very important. Pay attention. I'll
Okay.
write it. It's 3x over 2x minus 1 plus 5 over 2x equals 5 into x minus 1 over 2x into 2x minus 1. This is, it's not that easy because I don't have one fraction to cross multiplication, to do the cross multiplication thing.
Yeah, okay.
Okay, what's the first thing you're going to do before anything else?
Condition, because there's an unknown.
Very good. So we do the condition, which means
that should we do like for the last denominator, right? The one that's like the 2x the 2x minus 1.
yes,
Do we do that one?
2x minus 1 shouldn't be 0.
Should not be 0.
Which means x shouldn't be.
Which means that 2x should not equal to 1, which equals to x should not equal to 1 over 2.
Very good. That's the first condition. The second condition, you know that we have more than one, right?
Oh yeah, there's like what's it called 2x.
Excellent. 2x also shouldn't be 0.
Which means that x should not be equal to minus 2.
No, pay attention. This is a common mistake between all students.
Oh, okay.
X shouldn't be what?
Oh, right. It's it shouldn't be since it's 2 times x, right? Then we take x to the other side, be 0 over 2. It would be 0.
Yes.
Okay.
Okay. Yeah. Now, after doing this, what should we do?
Okay. We should probably simplify.
No. Look, if you have only one fraction to the left, you can cross multiplication.
Oh, okay.
But if you don't have,
should we then add the first and the second fraction?
I cannot add them because they don't have the same denominator.
So they have to make them have the same denominator?
Exactly. So if you have one fraction, you do the cross multiplication. If you have two fractions, then you have to make them.
Oh, you have to make them have the same denominator.
Exactly.
And then add them.
So what do you think you're going to multiply the first fraction by?
So let me just check.
Yeah, think about this.
Let me think about it. 2x minus 1. Shouldn't we multiply by? Well, we can.
Okay, deal with them. They are not numbers; they are terms.
Terms. Okay. So so for example, the right one does not have minus 1 in it. So should we make it have minus 1?
No, Actually, you cannot put +1. You cannot put -1. You
That's
can
the thing.
only multiply. You know this,
Multiply.
right?
Okay, so like basically we multiply the other side, both the first side we just multiply by 2x, and then the other one
Exactly.
by 2x1.
Very good. So I multiply by the term itself.
All
Okay.
right. So the whole.
Very good. So I multiply
Okay.
the first fraction by 2x, and I multiply the second fraction by بس عم اقول ليش ما ردش علي. Sorry, miss.
Okay.
Sorry.
Yeah.
You know,
it's
okay. 2 o'clock in Lebanon.
Yeah. So there's. Yeah.
Yeah, let me just write it again quickly. So we had, I'm not going to write the condition directly. So it's 3x over 2x minus 1 plus 5 over 2x. Okay, it's equal to 5 into x minus 1 over 2x into 2x minus 1. Okay, so we said that we have to multiply the first fraction by what?
By 2x.
Very good. And the second fraction by 2x
By
minus
2x.
1. Very good. Yeah. So here I'm going to have 2x. And here I'm going to have 2x minus 1. The same thing in the numerator. 2x minus 1 here. And 2x. Okay. Let us put them on
one fraction.
Denominator. Yes.
One denominator, yeah.
Which is 2x.
What 2x? 2x minus 1.
Very good. Equals something 2x over 2x minus 1. Okay, what about the numerator?
The numerator. So for the first one, 2x times 3x, it'll be 6x squared, right?
Very good. Plus.
Plus it will be plus 10x for the minus 5. We multiply
Very
5
good.
by minus.
Excellent.
Okay. And that's it. So then we just then the other one we write normally 5 into x minus 1 for the
5x minus 5. We can do it, right?
Yeah.
Now what's the easy step that we should do?
We can cross multiply.
We
or
cross
you can just
the
cross
denominator.
out.
Very good. Okay, is it clear?
Yeah.
That's the hardest part in equations.
Yeah, it's a bit tricky. It took me a while to figure it out.
Yes, but they are not that hard. That's the most one.
That's the most difficult one. Okay.
Yes.
That's good.
Okay. The others, just look at them. Let me just share it with you. All the equations. Okay, can you see them?
Yes, I can see them.
Okay, so sometimes you have to do the same denominator. Sometimes you have to take a common factor.
Yeah.
Sometimes it's
like
absolute value, same opposite.
Yeah.
Okay, but that's the hardest one. Can you see it?
Yeah. That's
okay.
those are the hardest one. Okay.
So that's everything about equations. So it's only solving in order to find the number of roots.
Yeah.
Okay, let me now start with inequalities. Okay, can you hear me?
Yeah, I can hear you.
Yes. So inequalities, first degree inequalities are very easy, and you used to solve this before in the previous exercises chapters.
Yeah.
Okay.
Yeah.
It's when you have an inequality and you're going to put the x to the side and the numbers to the side, and you put it as an interval.
Yeah, as an interval.
Okay, that was very easy. Just let us do this one quickly. So if we have x plus 5, it's less than 3, for example. That means it's x less than.
X is less than, we take part, so it'll be 3 minus 5, it'll be minus 2.
Exactly. And how do we write this as an interval?
Basically, we can write it as, what's it called? Since it's like an open circle, we've got an open bracket.
Yes.
do we just like write -2 or like
minus infinity till -2, right?
Yeah.
So that's the solution. So it's very easy to work on first degree inequality. Okay?
Yeah.
Now we're going, what you're going to take new is the second degree inequality or the third degree inequality. Okay?
Okay.
Yeah. So, like for example, Karam, when I tell you x squared minus 9 positive, okay? The first thing you're going to do is to factorize. So it becomes
yeah. So it
x.
becomes x -3 into x plus 3.
Very good. Look, if I tell you that the product of two factors is positive, what does that mean? Either both of them are
either both of them are positive
or both of them
are negative.
Negative. So there's discussion, right?
Okay, yeah.
That's why I need to discuss the values. Discuss them. Okay? How do I discuss them? This is very easy. Pay attention. First of all, I'm going to pretend that this is an equation. So what's the first step? Pretend that this is an equation.
This is an equation, a normal equation.
Yes, a normal one. So x minus 3 equals 0 or
x plus 3 equals 0.
Very good. So what are the roots till now?
Plus 3 and -3.
Very good. But we need to discuss these roots, right?
Yeah.
Okay, that's why we do something called table of sign. It's where we discuss their signs.
Okay, yeah, makes sense.
Okay, let me construct this table for you. In this table, we put like this, 2 lines. It's from minus infinity till plus infinity, as you can see. We put on this table the roots. What are the roots?
The roots are 3 and -3.
We put them in increasing order. So
yeah, so
-3
and then 3.
Very good. And now we put this line, first one. This is a line. This is a second line. The first line is for what? For x.
It's for the x -3.
Very good. X minus 3. Have you seen this before?
Yeah, I already mentioned that I tried to like understand the lesson before.
Oh, really?
Yeah. And this is x plus 3.
Yes, x plus 3. So, and now I put a line like this, line for, just a second, line for the -3 and line for 3. Very good. Now, what's the root for x minus 3?
The root for x -3 is 3. So
very
there's
good. So
going
I
to be
put
0.
Yes. Everything before 0
is negative.
After 0
is positive.
Unless I have before the x negative, they flip. So if
it's flipped, then we go the other side. So theirs is going to be positive, while
yes.
the one towards the positive will be
very
negative.
Good. So pay attention for the sign of A before you decide their signs, okay?
Yeah.
Okay. What's the root for x plus 3?
It's -3, negative
Very
3.
good. And the sign of x is positive, so everything is normal. Before the 0,
we have a negative, and then after the 0, we have positive.
Very good. So, Kalam, now I'm discussing the product, right?
Yeah, the product of it.
Okay. So minus times minus
is going to be positive.
Plus times minus
negative.
And plus times plus
is positive.
Very good. Now, what do I need the inequality to be? I need it.
You need to be positive.
Positive. Like, where's the positive? It's here. From this value to this value, and from this value to this value, the product is going to be positive. So how do I write it as an interval?
Okay, so open bracket, negative infinity.
Yes, till
-3.
Very good. It's also open.
It's an open circle. Okay, so open union.
Very good.
Closed bracket.
No, it's also open because we don't have or equal.
Yeah. Open bracket. What's it? 3, and then plus infinity. Open bracket.
Very good. That's it. What you are, this interval means everything between minus infinity and -3. If you replace it in the inequality, you're going to have a positive value.
Okay.
Okay. And if you choose something here, like choose a number between -3 and 3.
Just one moment.
Any number you want.
Yeah. My mom was just calling me. Sorry.
Oh, it's okay.
Yeah.
Reply if you want.
Just let me text over here. Sorry about that.
Yeah. So choose any number between -3 and 3.
-3 and 3. So for example, 2.
2. Replace it in the inequality.
Like the original inequality,
Yes.
like with the x squared. Okay, so be 2 squared will be 4.
4 minus 9.
4 minus 9, it will be -5.
Negative. That's why this interval, this place here is excluded in my interval because it gives me a negative value.
It gives you, it doesn't give you, it's not going to be greater than 0.
Exactly. Is it clear?
Yeah.
Okay, I'm not going to give you another example because you'll have a lot of exercises to solve, but we still have one thing. If we have a fraction inequality.
Okay, yeah, I will go into that because
Yeah.
I was doing one of the worksheets that was like in the original Padlet, right?
Yes.
And what I'd like the first question, it was a fraction inequality.
Yes.
So just like check that out.
Yeah, let us solve it. I'm going to give you an example. Like if we have, I'm going to give you x plus 3 into 4 minus x, okay, over x plus 1. And I want this inequality to be, for example, negative.
Okay.
What's the first step?
Okay, what's the first step here? What do we have here?
The same thing. You pretend as if it's an equation. Everything in the numerator equal to 0. Everything in the denominator.
Oh, it must not be equal to 0. We have to we have to find a condition.
Very good. So for the first one, x plus 3.
The first one, x plus 3 equals to 0.
Which means x equals?
Which equals to -3.
Very good. The second one, 4 minus x equals 0.
4 minus x equals to 0.
Which means?
That'll equal to -x equals to -4, which means x is equal to 4.
Very good. Now the third one.
The third one, x plus 1 must not equal to 0.
Exactly. Which means x is not equal to?
X is not equal to -1.
Very good. So how many roots here I have?
We have 3 roots.
3 roots. So I'm going to put 3 roots on the table.
Okay.
Yeah, now let me construct the table. So the first one here. Okay. The first one. The second one. And the third one. How many roots are there? 3. Let us arrange them in increasing order. This is minus infinity. What do we put first?
We put -3.
And then?
Then -1.
Then 4.
Then 4.
And plus.
And then plus.
Very good. Yeah. The first term is?
The first term is x plus 3.
And then?
Then 4 minus x.
Very good. And the last one?
The last one will be x plus 1.
Very good. Let us start with the first one. What's the root for x plus 3? Let me just put the lines, just a second.
Yeah.
Okay. So what's the root for x plus 3?
-3. So we put a 0 on it.
Yes. Everything before?
Everything before will be negative, and everything after will be positive.
Very good. Now, what's the root of 4 minus x?
Since it's minus x, right?
Very good.
Yeah, so basically everything before will be positive.
Bravo,
and everything later will be...
Amazing. Excellent. Now, x plus 1, you know that its root, it's -1, but it's not equal, right? So that means here I have to put it shaded.
We have to shade it, yeah.
Yes, excellent. And everything before -1 is?
Everything before -1, okay. So it's going to be negative since it's not minus x.
Yes.
And then everything will be positive after it.
Very good. Now we need to check the quotient because it's a fraction, not product.
Just quotient, yeah.
Yeah, but it's the same thing. Minus times plus times minus.
It will be so negative, positive, negative, negative, negative. It will be positive.
Very good.
Positive, negative, negative.
Very good.
All positive.
Yes.
Positive, negative, positive, negative.
Very good. I'm just going to put it or equal to make things different, because we had someone which is strictly. Yeah. What do I need it?
Okay, read it that it is negative, right? We need
Yes.
as negative.
So where's my region?
Your region is going to be, since it's like a closed circle, is going to be a closed bracket, right?
Yes.
We start from -3.
Very good. Till
-3 till -1.
Is it
or
closed?
4.
Is it closed here?
It's not closed here. It will be open.
Because it's shaded, right?
Because it's shaded, yeah.
Perfect.
So then
Union.
we put union, then open bracket, I think.
No.
Oh, we put
I don't have any problem with the 4.
Okay, so we just do it like that.
Yes. 4 till?
4 till plus infinity.
That's perfect. That's perfect.
Okay. Okay, let me just screenshot this so I can have reference.
Yes.
Okay.
That's more than perfect.
Okay, good. So that's all the questions that I really have for this chapter.
Yes. The second chapter after this, it's very easy, and I already have the lecture for you. But
is it going to be related to the orthonormal system, right?
Yes, but it's much easier.
Okay.
It's about vectors, but it's much easier because you're dealing with coordinates.
Yeah, okay.
Okay, but this lesson, I just made sure that we have this talk because there are important things that I need to talk about.
Yeah. That makes more sense. Yeah.
So that's everything. I'm going to send you after that, when we are done right now, I will send you directly the worksheet and you have time to solve it. Whenever you are done, just send it, okay?
All right.
Okay, Kalam. That's perfect.
Thank you so much, man.
You're welcome.
Okay, bye-bye.
Bye-bye. Bye.